Hello everyone, welcome back to my YouTube channel. I am Maunika from Sri Venkateswara College of Engineering, Department of Computer Science, BMW section, second semester, subject Applied Chemistry for CSE stream. Today we are going to discuss about corrosion and its basic types and other types. Corrosion is divided into two basic types. One is dry corrosion, other is wet corrosion. Now, let us know what is corrosion. Corrosion can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through the chemical or electrochemical reactions. Example, rusting of iron, a reddish brown scale formation on the iron objects, green scales formed on copper vessels. Corrosion may occur either in a dry environment or in an aqueous medium. The former is called dry corrosion and the latter is called wet corrosion. Dry corrosion. It is also called chemical corrosion. Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reactions. It occurs by direct attacks of atmospheric gases such as oxygen, hydrogen, sulfide, halogens, and sulfur dioxide on the metal forming oxide layer. Example, the attack of dry air or oxygen on metal to form an oxide layer over the surface. Wet corrosion. It is also called electrochemical corrosion. Wet corrosion involves reaction in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and an oxygen present in the atmosphere. Example, rusting of iron. In last slides, we discussed about basic types of corrosion. Now we are going to discuss about other types of corrosion like differential metal corrosion, differential aeration corrosion, waterline corrosion, pitting corrosion. Differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each another and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as an anode, undergoes oxidation, and gets corroded, and the other metal with higher electrode potential acts as a cathode, undergoes reduction, and protected from the corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. Example, tin coating copper vessel, steel pipe connected to copper plumbing, bolt and nut made up of different metals. Differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergo corrosion, whereas other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Example, iron rod partially immersed in NaCl solution. Part of nail inside the wall undergoes corrosion. When a dust particle sits on a metal bar, the part under the dust undergoes corrosion. Partially filled iron tank undergoes corrosion inside water. Waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. A distinct brown line is formed just below the waterline due to the deposition of rust. Example, ships which remain partially immersed in seawater for a long time undergo waterline corrosion. Pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous, crystallography directions are not equal in the reactivity, environments are not uniform with respect to the concentration. Pitting corrosion results when the portion of the metal covered by the dust, which is less aerated, becomes anodic and undergo corrosion and form pit. The remaining area of the metal, which is exposed to higher concentration of oxygen, becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area to corrode faster because accepting electrons from the cathodic area increases. Methods to control corrosion. The rusting of iron can be prevented by greasing, painting, galvanizing, anodizing, or oiling the surface. These methods can be classified into following categories. Galvanization. Galvanized metal is coated with a thin layer of zinc to protect it against corrosion. The zinc oxidizes when it is exposed to air, creating a protective coating on the metal surface. Alloying. It is a method of improving the properties of a metal by mixing the metal with another metal or non-metal. When the iron is alloyed with a chromium and nickel, the stainless steel is obtained. Stainless steel does not rust at all. Painting. Rusting of iron can be easily prevented by coating the surface with a paint which protects iron from air and moisture. Greasing or oiling. When some grease oil is applied to the surface of an iron object, then the air and moisture cannot come in contact with it, and hence rusting is prevented. Thank you. Like, share, and subscribe.